Hi, it is a section 3.9, inverse trigonometric functions. In this section, we'll study derivatives of inverse trigonometric functions. Let's begin with a recall from section 1.6. The sine function is oscillatory, so it is not one-to-one. However, if we restrict the domain between minus pi over 2 to pi over 2, then it is an increasing function and one-to-one, so that it has inverse, which is called arcsine. Here, okay, minus pi over 2 is minus 1.7, so okay, and from here, now that it's like that. So that curve is now y equal sine x, and restricts on minus pi over 2 to pi over 2. Okay. Then it is increasing function and one-to-one, and its inverse is arcsine, and the graph reflection from one to the other one with respect to here now y equal x. You can easily see that, right? For cosine, also we restrict the domain between 0 and pi. Then it is a decreasing function and it has inverse, which is arccosine. The same way for other trigonometric functions we defined is inverse. Now here, domain of the restricted domain of sine becomes range of arcsine. The same way, the restricted domain of cosine becomes range of arccosine. For other trigonometric functions, we can say the same thing. Okay, so we defined this one. Now, algebraically, we defined in this way, arcsine, y equal arcsine of x is now range. That is, range of arcsine is this one. That y equal arcsine means here sine y equal x. In this sense, we defined arcsine. Also for arccosine, here cosine y equal x, so that equation and that equation is basically the same. Okay, for other functions, really quite same way we defined their inverses. That is a recall, and now we'll try to find here the answer and just find the quantity for the inverse trigonometric functions. Okay, part A. Now, cosine inverse, sometimes we write in this way, that is arccosine and 1/2. We have to find this quantity. If we set it x, then that is the same as here half equal cosine x. Okay. Then you can easily find that here, from here. Now, that is basically now x equal pi over 3. Right? Then the value cosine of x is half. Right? The same way for other the quantities you can do it. Now, for example, again, part B, here, arccosine, no, we start with a small letter, arctangent 1 is now, we have to find this quantity. If we call it x, then that is same as here now 1 equal tangent x. Here the angle, so from here angle x must be now pi over 4, right? Okay, pi over 4, then the slope will become 1. Okay, now for this one, you can do it the same way. Okay, now we'll go to derivatives of inverse trigonometric functions. And we'll use implicit differentiation to get the formula for derivatives here. Okay, y equal arc sine of x, then that is the same as x equal sine y. So we are applying implicit differentiation. Then here left hand side, of course here differentiation is with respect to x. The left hand side is 1. Now y is considered as a function. So now we consider y as an intermediate variable. So we make a first derivative with respect to y. Then sine y will become cosine y, and y x derivative, which is y prime. So y prime can be written 1 over cosine y. Now that side, the right side, must be a function of x, not function of y. So we have to replace this term. Now there's no other here, the useful equation we used. However, now if we consider that one, your cosine for any theta, cosine squared theta plus sine squared theta equal 1. Always this is satisfied, so that if we move this to the other side and take a square root, then here cosine theta will be plus minus square root of 1 minus sine squared theta. Okay. Now, but here we chose only the positive one because, okay, right now, and sine and arcsine here, and sine function to be 1-to-1, we restricted the domain here now minus pi over 2 to pi over 2. And in this area, the cosine y is here positive, not negative. In fact, here cosine, graph of cosine is given in this way. Here, and it's passing this 1, it up and now go down, right? So this is pi over 2, minus pi over 2, and pi over 2. Here, that is y equal cosine x. That is x direction. We know that. So that in the y is between minus pi over 2 to pi over 2, then cosine is now on the positive except at edge points, so that we can write in this way. We are choosing only positive. And here, sine squared y is the same as x squared. So we replace sine squared y with x squared. We end up with that. Of course, over there, the denominator cannot be 0, so that x, the value must be less than 1. So anyway, here y prime, once y is arcsine of x, then its derivative is 1 over square root of 1 minus x squared. And for cosine, you can do it exactly the same way. How about arctangent? Okay, y equal arctangent of x, then that's the same as x is now tangent to y. So again, we apply implicit differentiation. Then here, left hand side will become 1, and right side, if we consider y as the function of x, then differentiate it with respect to y, then that will be sec squared y and y x derivative here y prime. So we reach y prime is 1 over sec squared y. Then sec squared y, we have to replace here this whole thing to become as a function of x. So here we are using that formula. This one can be gotten here from that equation. If you that equation is divided by cosine squared theta, then that will be same as 1 plus sine squared over cosine squared is the same as a tangent squared theta equal 1 over cosine squared is now sec squared theta. So that sec squared y is changed by here 1 plus tangent squared y. Okay. Now tangent y is same as x, so that we can write finally y prime is 1 over 1 plus x squared. Y is arctangent to x, and its derivative is 1 over 1 plus x squared. For other inverse trigonometric functions, you can derive the derivative exactly same. So here, okay, we summarize the results. Okay, here for arcsine, arccosine, and arctangent, arccotangent, arcsec, and arccosec. And here, if you see the pattern, then for arcsine, we got that one. For arccosine, the derivative is exactly the same as now that of arcsine, except here minus sign. Here arctangent and arccotangent, their derivatives are same except only that sign. Same here, arcsec, arccosec, and here we have minus notation here, negation here. So except that, so here start with a C, arc cosine, arc cotangent, that is start with a C, and again start with C, then we have here minus notation, minus here, okay? Okay, so it'll help you to memorize part of that, but it's not easy to memorize. So in exam and any some event, you can try to see this table, and also I'll provide a table. Okay, let's try to solve these problems. Find the derivative of the functions. Okay, now y prime, okay, change the color, and y prime equal, already we know that here arcsine, once it is here x, then, and also we consider this as x, a variable, when now, okay, that is x, momentarily we think this is x, then now we make derivative with respect x, then which is same as here 1 over and square root of 1 minus x squared. So look at over there, that one. We are using that formula. So that is the square root of here 1 minus x squared. That is square root 2t is x. The square is now 2t squared. And we have to multiply derivative of this term with respect t, which is square root 2. Okay, you can simplify if you want. Now let's go over there. Now, okay, y prime. Okay, first we consider this whole thing as a variable, then the logarithm, natural logarithm, derivative is basically here now 1 over x. If you consider this one as a function of x, then logarithm, okay, we already know that. Okay, we'll try to use this one, f of x. Then we try to make now x derivative, then that is same as f prime over f. We already know that. Okay, we'll try to use that. Then, now that will be arc cosine and 9x squared. And then the top must be now here arc, okay, we'll write down here. Oh, no, arc cotangent. I'm sorry about that. Here, that is arc cotangent. Okay. Cotangent, 9x squared, arc cotangent, and 9x squared. And here we have to make derivative. So we focus on and only here numerator. Okay, so the numerator is arc cotangent 9x squared. So now we consider 9x squared is a variable. Then its derivative is the same as minus 1 over 1 plus the variable squared. So the 1 plus, okay, variable squared is 9 squared is 81, and x squared is x to the 4. And then here 9x squared derivative must be multiplied. There's 18x. So you can replace the numerator by this term, then that will be the answer. Okay. Okay, let's go over there. Now, okay, for that one, rather than arcsec, we use notation sec inverse. Okay, anyway, that is a variable 5s. So y prime, what is arcsec derivative? Derivative of arcsec is now that one here, 1 over x absolute value and square root of x squared minus 1. That is derivative of arcsec. So here, now 1 over the variable absolute value, so the 5s. Okay, and then square root of the variable squared, 25s squared minus 1, right? Yeah, we are using that formula. And now, for the variable, you have to make a derivative, which is now 5. So here, if you simplify, then there is 1 over. Here, 5 will be cancelled with this 5. So that is absolute value, and square root of here 25s squared minus 1. Okay. Now for that one, y prime equal, okay, this is product of here x and arc sine, so that you have to use product rule. So first we make a derivative with for that one, so which is 1. So here arc sine of x and plus. Now here x times and arc sine, already we know that its derivative is 1 over square root of 1 minus x squared. We derived that one here from here. So it's 1 over square root of 1 minus x squared. So that is 1 over square root of 1 minus x squared. Okay. Now, we have to also put the derivative of that. Okay. That is plus. And that is the same as basically 1 minus x squared half power. So first we think 1 minus x squared is a variable. then the variable half power, so that is same as half will come out, and here 1 minus x squared, half minus 1 is minus 1 half, and we have to multiply the variable, derivative of the variable, so 1 minus x squared, its derivative is minus 2x. Okay. Okay, let's try to simplify this one. So that is arc sine of x and plus x over square root of 1 minus x squared. And we have here negation, so that minus and half and 2 will be cancelled out. And this term is the same as 1 over square root of 1 minus x squared. So there's x on the top and bottom. Here we have 1 minus x squared. Okay, this one, that one will be cancelled out, so that we reach that is arc sine of x. Okay. Okay, that formula will be used later from chapter 5 in calculus 2, and later on here. Okay, now from y to y prime, so that is differentiation, and the opposite operation is called integration. Okay, we are using usually the notation. Okay, if I make it better, that is given there, right? Okay, so that is called integration. So integration of that one is the same as, okay, let's try to use this one. Integration of arc sine will be same as that one. And here, of course, even though you start with any constant c, and you are reaching the same thing, same arc sine x, so that here integration of this one is same as that one. We learn, you will learn this one in calculus 2, the integration. So we'll use this formula for the integration of arc sine. Okay. Okay, this is end of section. Thank you.